Okay, so the whole point of this series that when I started is with an intention that the end of the day you should be able to write your own plugin and you should be able to actually understand the Gazebo Sim repository code. That's very important for you to become very good efficient in making Gazebo Sim plugins. And in this video, we are going to take an example from Gazebo Sim repository. So if I go onto this repository, this Gazebo Sim repository, currently we're using Gazebo Sim version 8, but it's fine. So if you go inside SRC, because we mostly discuss about system plugin, you'll find lot of system plugin over here and there are many examples. But there is a certain way that you need to understand this code to understand them better. So we'll discuss that method, what is pimp, pointer to the implementation and things like this, so that you'll be able to understand this code much better. And if you have really followed around this plugin tutorial series, you should be now in a much better condition to understand the real Gazebo Sim GitHub codes. That is the main target of this entire tutorial series, that I make you so much enabled that you're able to understand all of this. So if you're able to do that, that means you have really consumed everything that I was trying to teach you in this entire tutorial series. Okay, so there are some pro tips that I want to give you to make for you to help in writing better plugins, Gazebo Sim plugins. So the first one being is that you should have very good understanding of Gazebo Sim API documentation. You should read them all in detail, like this Gazebo Sim and then entity component system and then component. From this, these are the three most important pages that you need to go through for you to understand what are the available APIs and how you can trick things up and what are the functions available for you. Okay, and but from this the most important one is this component, because even the first time when you start writing, even thinking about any code that you want to make, any plugin that you want to make, you should first check what are the related entities that's available related. For example, if I'm searching for joint, what are the related components that available for joint? If I'm searching for a light, what are the related components that's available for light? So if you know what are the component, then you'll able to make code it better. If sometime it may happen that you might not find a component that's very much needed for your use case, then you will have to find workaround to make it happen. Or it could also happen that that plugin, that component is not yet available in the Gazebo Sim. Okay, so but the thing is that this is the point where you should firstly think and start, before even start coding, you should look up for the component, available component, their message type, what are the details. We discuss all this in the tutorial, but this is the where you have to focus even before writing up your codes. And then the next point is, if you have really followed along this tutorial series, there is a page. If you're reading these documents that I've written, then there is a very good page that I've mentioned on this document where I have written all the common code. Basically, it's sort of a cheat sheet which has all the details that we have discussed around the code, what are the functionalities. So if you go down, you will find this find entity. What are the different method that you can find? First one was if it is attached to this model, then search by entity name. So this has entire cheat sheet of what we have discussed in this tutorial series. There are different ways, A, B, C, D. That means there are different method to make it happen. And then this is entity by component. And then if we go on to read, what are the ways to read and write on the component? This is way to read, then this is way to write. So you can use this as well to find a different ways. It doesn't have everything that you need, or there are so many methods more than this. So that's definitely not possible to make tutorial on everything, right? I can't make a tutorial on each API. That's why I want to give you a framework at the end of the day, so that you can make your own Gazebo Sim plugin and you're able to read Gazebo Sim codes. That should be your target, that you're able to understand the actual Gazebo Sim code. And I would be very happy if any one of you following this tutorial along, you make some updates on to Gazebo Sim repository. So that should be your target following this tutorial series, that you give back to the community of Gazebo and you make some crazy and amazing plugins for Gazebo Sim. So this was the tip number 2, and then the tip number 3. This could be a little bit controversial, but I would say there are so many LLMs that's there that you can use for your use case. You can use ChatGPT, Claude, Gemini, or Perplexity, or there are many others. So you can use them to find out examples, other things, and you can use them to find out good example. You can ask them to what are the codes that you can find, and many other things. Like, and you can also find ask them to what is the issue when you build the code. Many times you will feel that you're doing some silly things and your code build fails for so many times, so you can ask gpts to help you out with that. You can use free versions. I'm not saying you should purchase some version, so this is getting very general in, but here is the thing, that if you're using this any chat gpt or something, you should not be doing wipe code. Wipe code means just copy pasting the plugin and you're saying no, I understand this plugin. No, so you should not be doing that. You should not be doing that, because first of all, that doesn't make you a better software developer. That doesn't make you a better robotics simulation engineer, or you won't really get anything out of it. And those sort of code that gpts write are very worst in maintenance. Like, if you go on to real industries, those code are not at all good for maintenance purposes. So you can use it as a replacement of a google search, or it's more like a google search and steroid, which you can use to understand what you want to get out of it, to find out example, to find out repository, to understand a particular gazebo some repository code. For example, over here I've asked this code, that even we are going to discuss this code, so I've asked it to make it in .md file, and then it has given a detailed explanation what are the going on the plugin and all those things. So you can use, for example, like this or some other way. But remember, you should not be doing wipe code. I do not want that at the end of the day you are just copying pasting from ChatGPT and it doesn't make any sense to you, and you are not able to maintain that code later. So you should be very careful around this, because many people just copy paste the code. I've seen it. You should not be doing that. Okay, then the point number 4 is that you should start reading Gazebo Sim repository codes. So I hope once you have completed this entire tutorial series, then you should be in a good position to understand actually Gazebo Sim code. Although the Gazebo Sim code has much better architecture, they are much better written, they're very much clean code. We didn't do in this tutorial series in that much standard, because the main purpose of this tutorial series was to make you understand, not to make complex things of design pattern and all those things. So that's why I made it really simple. But if you start reading Gazebo some actual codes, then you will understand much better, and some design techniques and some structure that you should follow along for making a better coding standards. But there is one common thing that is being very much used in Gazebo Sim codes. If you do that is called pimp. So this is pointed to the implementation. So it is an idiom, and it is sort of a pattern that is being used a lot in Gazebo Sim repository. Let's first understand what is this pimp pointed to the implementation. So let's see on this example that basically you take all your code from .h file and half of the code you copy to .cpp file. We'll understand the reason why we do it. First, let's see the code. So the step number 1, my actual class is this my class, but I have made a private class out of it. This is called forward declaration, when you are not defining the class, but you are just declaring the class, but you are not defining, and you define it in then C++ file. So over here, this is my class, and this is constructor, descriptor, and this is some function doing something. But the important thing over here is this data pointer. It is referring to my private class. It is making, because we wanted to have this class for here, we wanted to make a pointer from this. So basically my class a pointer that point to my class private. Okay, so we wanted to make this, that's why we have declared it over here. Now we are going to define it here, and you'll see everything that you can put on the private member. Instead of doing that, we made a pointer out of it, but we'll understand why it's being done in open source repository. There is a very good point why it's done. First, understand this code. So in my class, you are basically defining your variables, and then you are defining your functions as well on the class. So this is private, and then what you're doing this. So when you're calling your constructor, defining all your variables on the private, and then on your constructor you are making the standard unique pointer. That means you have given access to this pointer, that's basically is this class. So now using that data pointer you will be able to access anything from here, and you can use it for doing anything, like do some function. There we are calling this internal logic on this class, that just brings hidden logic in the plane. So basically this private variable that is coming from this my class private. So if you define it like this, the main benefit of doing this, why this open source repository has this pattern, is that, so what happens if in your .h file also, in your .h file, if you keep on changing your private members, then what happens, you have to rebuild your code, and also it's not compatible. So to handle those sort of things, so that it compatible between, like, let's say Gazebo Sim version 8, 9, 10. So to maintain this compatibility check, we use this pattern, so that because you are using this as one data member, and later on this you are defining all your variables, whatever you wanted over here. So what happens, you do not need to recompile it. You just, your cpp code just gets recompiled, because a h file remains as it. As well as if you see, in that h file we are just giving a minimum things that's needed for this code. Okay, this just bare minimum, and the most of the thing we are including on .cpp file, all the header are mostly included over here, that is being used by this. So even on h file you're not even changing your headers file, so it doesn't need to recompile. So that's the main benefit of having this in open repository. This is very common practice. So, and this is the same thing that I've written over here, that it's a fast build because your h file is no more compiling. And then your binary compatibility, the same thing that I just told you, I've written over here. So because my class remain constant, and your my private member you can add on, so it's very easy to add and delete on things on this private class, because this is just a pointer that's going to point to my class, and through this data pointer, and you are not changing anything around this. So that's very good for compatibility. And clean header, I just told you that here you're just adding up the basic minimum things that you need, and on this then you add on all the header files that you need. So this is very much good for open source repository. That's why they do it. Now I've done one changes, the same pattern I followed in one of our code, and that code is also going to help us out understand velocity component. Velocity, I think, what's the plugin name, I forgot. If I search over here, velocity control. So we have written a similar plugin like this. If you remember velocity control, where there were 3-4 methods that we discussed with velocity control. If you haven't watched that video, please watch them before you go forward in this video, because I'm taking a reference from here. And then we control this with GG topics. So this is similar code, and first time, before even starting making this tutorial series, this is the code that I actually referred to make this. Okay, so this is the place even I refer to make this tutorial series. So if you go inside this code, it will have all the details. But before we discuss this, I made changes to the one of the code that we made it. Okay, so if you remember this one, this is the one plugin that we wrote when we are discussing how to have model plugin with GG topics, GG transport topics, and this is the same thing that we're doing from here. So this is very similar. What's there on this plugin as well. So if you see over here, so this plugin that's there in Gazebo Sim repository, this is the similar code that uses the similar technique to make it work. So make sure we have read this code, but now we are going to trick something on this code. We are going to add this pimp logic, that pattern that we just discussed, this pattern onto our code, and I will explain you that. Then we'll go on to this code and we'll understand this code as well. Okay, so as I was saying, I added one more folder onto standalone Gazebo Sim plugins. So on this code, this is just a copy of topic way plugin. I just added pimp so that I can explain you the entire concept of pimp. And this, everything is same, the logic is same, everything is same, just we have added pimp pattern onto it. So let's try and understand what is the thing that's there. So first of all, over there, as we were discussing, I have also made a private class over here. the name, and now I've changed the class name so that we do not get confused. This I've added the pimp word, but the main thing is this private. So entire class name is move model topic way pimp, but I've added this private so that at the end we can define this data pointer. Okay, so if you see on this code, that we are making a data pointer using this private class. Okay, and then on this file we are going to define it. Even on here we have just one header file, and the entire thing that we earlier had over here was this, all the private variables and functions that we had, like this model name, topic name, everything will be copied over here. Okay, so everything is getting copied just from here to here, and you get a version where it builds faster. So why not to do it? Yep. So here I've included all the other header file that we needed. So everything just copied from this header from here to here, because everything is big defined within this private member. Okay. Now if I just increase the size of this, so most of the code are over here on member function. And what are the changes? We just made this private, and then on the constructor, this is important, and on constructor you need to initialize this, making unique pointer out of it. We made a unique pointer out of this private class. Now this unique pointer we are going to use for getting everything configured. For example, the model name. So how we access, earlier we were using this and this model name, because at that time it was the member function of this class, right? Move model topic way pimp class. It was a member function of this. Now because everything has become a member function of this private class, we are using this data pointer to point to this. So this data pointer is the one that replaces this, and everything, if you see, if I just mark this up, so you will see every data that is there within this, we are accessing it with, because it's now the member of that class, and we made an object out named data pointer out of it. That's basically a pointer, and that's pointing to that class, and every function that you see is not getting access. Same is with the class as well. So earlier on this class we were defining it with this class name, right? This model move model topic way pimp, but now we have added this private because it is now within private. So these are small changes that we have done. Now everything is same, just on this also we have added this, and on this earlier where it used to have just this pointer, now we are using this data pointer to get what this get returns. It just returns this pointer that is there. So it returns this for the private class, for this private class. Okay, so that we can access and we can link our class. So these are, everything is same. See, the entire code and logic is same. It's just now how we define, how the syntax is there. Everything has gone to pointing to the private class. Nothing special around this, but I wanted to explain you so that you are aware before reading Gazebo Sim repository that this is something you need to be a little bit careful around. And where is the place to find all of your code, we'll discuss in an example. So this is, everything is same. So I've already built the code just to make you sure that it's the same thing, nothing I'm doing different. So it's the same thing that's there in that plugin, and it's over here. And make sure you have watched that video, otherwise you won't understand anything that I'm telling you on this. Okay, now let's check the code of this Gazebo Sim repository velocity control. Okay, before even I explain you this h and cc file, let me explain you let me show you the SDF file as well. So if you go on, if you just search this velocity, you'll find this SDF file, and this is the SDF file that's using that plugin. So this is how you can find out all of the things. And if you go down somewhere, so on this plugin is attached to the world. No, this is attached to a model, sorry. This is within the model space. So this is attached to the model. And then this is status of initial linear velocity and initial angular velocity. Okay. So now let's open the code and we'll go on to the SRC and we'll try and understand the code. And then velocity, yep, here is the velocity code. Let me open this in a new. Okay, now I've arranged this. Now first of all, what this code does is it just controls velocity of model and links that it is attached to, and it also scribes onto a topic that it can use for controlling those. So every detail, it's a good thing that on the comments, if you see, they have mentioned what it does and what is the topic that you can use for commanding the models. And then you have setting the linear velocity of the start and linear angular velocity. So if you publish onto this, then you can control entire model and their relative links velocity as well. Okay, so let's understand this code. But before that, let's see, is there pimp on this as well? It is there. So if you see, this is forward declaration, and this class name is velocity control, and we have added this private variable at the end of it, right? The same thing that we just discussed. And if you see, and then this data pointer is there, this is pointing to this private class of velocity control private. Okay, so this data pointer, now if you come on to here, this is the same class where they have defined every detail of it. So you have to read this first, then you should always search for the private class. So most of the code on Gazebo Sim repository that I've seen has this pimp. If it doesn't have, then it's just a simple plugin, okay, that you can easily understand. So on this, what it is doing, it's subscribing onto command val. That means it is using what? It is using GZ transport somehow, okay? That's why this has this message. And on link command as well, it is having link, it is also taking the link command. Now its update is update the velocity, updates the link velocity. Now this is basically H file, and also the all the header files, they are here, no more here over here. They have just put the optional ones that's needed for this H file to compile, like system, optional memory, nothing special, and all the details they have added over here. So it's very easy when they update the code on in future, they're able to make update properly, and it won't break any changes on the previous versions just because of the pimp implementation that I just explained you. So this is the private member, and then they're using the same standard data pointer, and they're accessing everything like just we discussed, like this only, the same code, entirely the same method. Okay, let's try and understand the code, what is happening in this code. And let me make the screen full, and we'll understand what is there in the code. So in this code, I just told you, as the subscribe onto command val velocity and command link velocities, then this update the velocity, then it updates the link velocity, and this has the GG transport node. Obviously we'll need GG transport to make topic subscription happen, right? And this is the model thing, then this angular value, these are some sort of variables. Then on the config file, they are just reading up the all SDF thing that we just saw on that SDF file. So they're reading the linear and angular velocity. Then they're reading if there is any topic they have mentioned, then you can push on to this link name if you have mentioned. If not, then these are the normal things that you set it from SDF file and you configure. Then somewhere on the configure file, here on the subscriber, they are calling this subscriber to subscribe onto command velocity, so that we can update all the model related velocities. Same goes with the link, they're subscribing to all the link velocity. So this is GZ sim link and model velocity that you can publish from the terminal. You can also clone this code and build it up the same way that we build our standalone Gazebo plugins. But the main point is I'm trying to explain you this code so that you understand the methodology around how to read any Gazebo Sim repository code. Okay, then on pre-update, if you see what all the things they have both pre-update and post-updates. We'll see why they have both. So this pre-update is there, and then there are something called profiler. You can Google this, what is profiler. This is just making to monitor the things in Gazebo Sim, how the code is performing. For this, the profile is there, then this time thing is there, and the same pause. Then because we have to read angular velocity commands, we are using this component of angular velocity command, and we are reading the component velocity, and this entity, we got the model entity which is attached to it. And same goes then for getting the links. They are using this loop to find all the links name. So they are searching link by name, based on the link, the name that's there, they are searching by that, and they got all the links. So they had model by default, then they got all the links that they needed. Now what they are doing, they're iterating over updating all the link velocities. So this link velocities, they must have stored somewhere, right? to update those. So if you see this step, what it does, it updates the link velocity. This is for reading purposes. This entire thing is for reading. Until here they are just reading on the command. Now they're updating the link velocities. They're updating this link velocities and link and model velocities. So let's first see from where this velocity commands are even getting to them. So if you see on this post update, once pre-update you update all the properties, on post they're reading this, so they're updating on update velocity. Okay, this function is there, they're updating the update velocity and they're updating the update link velocity. So they're just updating link and update velocity on post. Why? Because post is for reading purposes, right? Post is just, you can read all the state. Once your physics is done, you read the states. For that reason it's there. So now they're reading post. And if you remember this message conversion that we did when we were learning about light control plugin, and over there also they are converting their messages to make it store into link velocity angularly. This is just a vector. They are storing link and linear velocity and angular velocity, and same goes with update velocity and same goes with update link velocities. So they're also doing the same message conversion and they're storing this all list onto it. So what happens? So if you go onto the configure, first of all, what happens if I explain you little bit the code? What happens? Someone publishes on the command well, whatever it is, the model, whatever is the topic name, from that it just come to this function of update velocity. Okay, then on this function, this command well must be storing somewhere some velocities, right? The current velocity. This velocity get feeded onto the list that they maintain. On this list they feed this up. Then from this list they update the velocities, on which they update all the velocities on pre-update step. Okay, on pre-update step they update all the velocity. So they read from this command well through callback function and they store this latest values of link and of model both. So they update this velocity, and then on update velocity or update link velocity they store this on the list by converting it, and then they pass on this list on pre-step to update everything. Okay, sorry for the little bit the way I've written. I hope that you're able to understand this even with the very silly handwriting that I have. But yeah, but I would suggest that read this code. It's not difficult. I'm trying to go through the code and I'm explaining you the certain things. Other than that, you should go into this code and read some of the details from this code, and then over there you're just setting up the codes. So on post update, this update step is happening where you update your update velocity and update your link velocities. So both are getting update, and from where this list is coming, this target val linear velocity, see, as I was saying, this target val linear velocity, this one is coming from on command val. So this is a callback function. When you subscribe, this values get into your message and this is the latest value. And because they keep on updating, so they convert this message that's there on this message method, messages twist, they convert it into a message format that can be consumed by the component. Same goes linear for angular velocity, and this is the same for model and link both. Okay, so then they update this velocities. Now you have entire list of velocity. Now if you go up, what is happening on the update step? First they're updating the update step of all the models. So first they already have the model. They are just updating because on pre they already got the model, because this plugin is attaching to the model. So they already have the entity that they needed. On this tab, they're just updating all the angular velocities. And where did they got this all angular velocity? They got it from update velocity steps that runs once you're done on post update. From there they are getting, and this angular velocity is coming from, actually it's coming from this target velocity. This target velocity, so this goes to this angular velocity, this there on update velocity function. Then from angular velocity this gets up to this pre-update step where they update the step. So this code basically flows from down to up. Okay, but how did I understand this? So even I think you should be getting most out of it. If you're not getting that, make sure you have watched all the related videos that we follow a pattern. So over there they have just made a better coding standards. Okay, this just that thing is that, but still everything that we learned on the component still same. Nothing has changed. So set component, that we learned this, right? We learned the set component. Then on the post update, if I show you, we also on the post update this function, we also learn reading the component. I don't think, are they reading the components? No, they are not reading it up because you are getting this component from on command well. But I think they are reading for links. They are reading, yes. If you go on to, if there are links, create the links. So on this tab they are reading those data link by name, and they are getting the entity for those links. So here they are reading all the link list. So we discussed for model by name, if you remember. So similarly there is link by name. Now this code should make a good sense to you because we have understood everything, and it's just that they followed a better design method. They have put better documentation, and they have coded it bit better. It should be done for an open repository, right? So that's the only thing, and I hope this code you are able to understand. If not, just go through this code once, okay, and you should be able to understand this code easily. I hope now the entire purpose of me making this tutorial series with this video is going to get fulfilled, and I'm able to make Gazebo plugin easy for all of you, and you're able to understand Gazebo Sim plugin much easily. And now Gazebo Sim plugins should not haunt you, and you should be able to read Gazebo Sim plugins repository code and all the things. And I hope I'm able to make Gazebo Sim plugin simplified for you. So keep learning. See you.